Hello, this is Jackson Lee, and this is my Lab 2 for Physics 2, Charge Tape Revisited, which is a variation on the past lab, which was charge tape. So the purpose of this lab was to create a model of two charge tapes acting as line charges, and then we are going to compare the results I get here to my results from lab 1. The assumptions that we're making here are that gravity points in the negative direction and it is 9.8 meters per second squared, that the air resistance is negligible, that the tapes are line charges, and that the charge of tape is evenly distributed. As you can see here, we're using one tape A to levitate another tape B. So the main physics principles here are Newton's second law, which states that F equals ma, or F equals m d squared r vector over dt squared. Coulomb's law, which states F equals kq1 q2 over d squared, which states the amount of force between 2-point charge, amount of force that electric force that a point charge exerts on another. Then we have gravity, which says that Fg equals mg, which we covered on the last slide, and g was covered on the last slide, and the distributed charge of an electric field is this equation down here, which will allow us to calculate the tapes as a line charge. So our results from lab 1 are shown below. As you can see, we've modeled tape A and tape B as a line charge with Fe and Fg vectors directly counting after each other, putting the system at equilibrium. And so from these results, we see that the charge on one piece of tape is roughly 6.38 times 10 to the negative ninth coulombs, which is slightly larger than the observed charge that I used hand calculations for. And then we also calculated that after ripping off the U tape, we lost roughly 3.99 times 10 to the 10th electrons. The U tape was the tape that we used to charge the other two tapes in the first lab. So we attached the tape and then ripped it off, which charged it and took many electrons with the U tape, giving it a positive charge. And so the potential errors for this lab were that we didn't factor in air resistance. We assumed the tapes to be point charges, and the tapes had to be recharged many times. So building off of lab 1, here's my lab 2 code. As you can see on the left, we have the physical constants and the lab 1 measurements, which will be the same from the first lab. So we have the tape width, the tape length, tape mass, and the distance between the tapes, which is the same as the last lab. And then up here I have my electric field calculations. Right below the electric field calculations are the line charge calculations. And on the next slide, I have my superposition calculations. And I also have my net electric force and gravitational force calculations in this code right down here. So the results from lab 2 can be shown above. As you see, we have many vectors from tape A, which shows that it's a line charge. Technically, that is infinitely many vectors since it is a differential distance between each charge. And then so we have this is the conglomerate electric force and the force of gravity acting in equal and opposite directions and equal and opposite magnitudes. And so from this, we calculated that the magnitude of Fe on tape B, the electric magnitude on tape B is roughly 1.23 times 10 to the negative 3 newtons if tape A acts as a line charge, as seen in this diagram. And we also see that the magnitude of charge on one piece of tape is roughly 1.5 times 10 to the negative 8th coulombs, which is only slightly larger than the estimated 1.499 times 10 to the negative 8th coulombs. And the potential errors are that we did not calculate with air resistance. We assumed both of the tapes to be line charges, and the tapes had to be recharged many times due to extensive handling, which means they might not have the original charge. So for the what if and why section of this report, what if each tape was modeled as a point charge like before? As you can see, the lab 2 model is an order of magnitude greater than the lab 1 model, or than the lab 1 calculations. And then the why was, why do these estimates differ, which is more likely to be closer to the real value, and why? For that one, I would say that they differ because the first one was a point charge and the second one was a line charge. And the line charge is definitely more likely to be closer to the real value because an evenly distributed charge is closer to what is happening in real life, as electricity doesn't work where there's just one charge at the point of mass of an object. There's going to be evenly distributed charge across the whole object, or at least in this case, the charge is going to be evenly distributed. In all cases, it's going to be across the whole object. So that is why the line charge is more likely to give realistic results. Thank you for listening.